So let's get to it. Let's speak about AlphaGo. AlphaGo is, as I said, this push from this DeepMind company to create a computer program that could play Go. We said in our previous presentation about the history of AI that Go was hard for computers. In 1997, IBM managed to create a computer that played chess better than humans ever could. And that had kept on developing, but Go was considered much more difficult. Up until this point, any good human Go player, and good means club level, so many people in the world, could beat the best Go playing computer out there. But in 2016, this DeepMind company decided to change things and to go about creating a Go playing program differently. And the difference was that they decided to use deep learning. So here I have put the link to the AlphaGo documentary in YouTube, and I'm not going to play it or use it, but it's public, I'm pretty sure. It's from DeepMind itself, and I'm going to list here a couple of particularly interesting points. This is a very nice movie to watch if you are remotely interested in deep learning and technology in general. It's a very well done movie, and it's a very long advertisement of this company too, and the way they achieve this programming feat. But I heartily recommend it. I think it's very fun, and it also shows quite a lot about how this system works. Basically, Go is very hard for computers because the board of Go has many possible configurations. So at any point in Go, there are many possible things that can happen, many more possible things that can happen than in chess. So let's just see a game of Go. I'm going to Kosumi, which is a public online server where you can play Go against a computer. This is a 9x9 board, which is not so big. Usually professional Go is played with 19x19, but because I wanted to show you a little bit about how Go is played, I went for a small board. And basically I'm black and the computer is white, and we want to place our pieces, our stones are called, in the intersections of the board so that we encircle as many pieces from the other player as possible. Whenever a group of pieces has adjacent pieces, these don't count as adjacent. These now are adjacent. This is a group of pieces. One group is loses its what are called degrees of freedom. So whenever a group of pieces is completely surrounded and has no empty spaces around it, it dies. It's said to die. Okay, so the goal is to try to encircle as much of the board as possible, also including the pieces of the opponent, without getting your groups killed. And as you can see, well, my rival is trying to get this part, my computer rival, and I'm trying to get this part, and in the end we will count who has more. So I'm going to be a little bit daring and try to get there, because I think maybe I can win something by breaking down these groups. He's not letting me. I'm hoping that maybe I will be able to break down his two groups here. I'm not very good at this, okay? So now he will probably connect this. No, he doesn't care about this, so I will probably, as you can see, we play one turn each. At this moment he's connecting this, so am I, so he's probably got all this part. I think I'm beat, but let's see. This, I think I have to stop here. Now he's playing there, which I respond with this. He has to do that, or I will go in. Yes, now I ensure this is not broken down here, and he makes me do this. and probably I think the game is mostly over. When the territory gets, let's say, settled, then the players pass. So he passed. Now I don't think I can get into here without my pieces dying eventually. So I will pass too. And now the points are counted and I lost. So I encircled less territory, less squares than my opponent, and I lost. But as you can see, Go is a game where at every possible moment you can play any of your stones basically wherever you want in a pretty large board. The one I showed you is a small version. This is played in a 19 times 19 board usually. Let's see it. I don't want to replay the game. Let's see what the board looks like. Okay, so this is the Go board, and we would play here. So at each possible position, at each moment, we would have many possible things to do, many more than chess. Also, it's not easy to define rules for what is good and what is bad in Go. So this is likely bad because I'm leaving my pieces in a very small space, but that's very difficult to code and to define. Actually, this is probably bad, but doesn't have to always be. Because of that, Go is a very hard, extremely hard game to code for computers. And until 2016, humans were much better at it than Google. But in 2015, AlphaGo, this computer software using deep learning to play Go, defeated the European Go champion 5-0. The European Go champion Fan Hui. This is explained in the movie, in the AlphaGo documentary. Go is not super huge in Europe, but this guy was a good player, not top level player, the world level player, but a very decent player, and he got defeated by this AlphaGo. And you can see in the documentary how when he learned that he was to play a computer, he kind of got disappointed because he had done that and he could easily beat them all, and then he was surprised that the computer was so good that it could actually destroy him. In 2016, with lots of publicity, the game was tested, the software was tested against a top level player of a game called Lee Sedol in a huge televised match with many people watching, commentators. You can see all about that in the documentary. And AlphaGo won that match 4-1 in a seismic event comparable to the 1997 defeat of Garry Kasparov by Deep Blue. Not only that, not only did the computer win, but at some points it made moves that appeared creative to the audience and to the experts analyzing the game. What does even creative mean? It was clear also that AlphaGo did not play like a human. The creativity thing showed that the deep learning powered computer could see moves that humans in general could not see, could have these flashes of, what is it, ability to compute, or is it just intuition? Well, maybe the two things are the same. It's hard to define. In the same documentary, the human player, Lee Sedol, makes one of those same moves. He's probably not able to compute in the same realm as the computer, but he has intuition and he has experience, and he can see some of these very good moves that most people could never see. So the computer can do them, the human can sometimes also do them, perhaps not as reliably as the computer. But at the same time, AlphaGo does not play in the same way as a human, and that's probably very disconcerting for the human player when AlphaGo realizes it's not a living entity, which is something that we will speak about later. But when the evaluation function of the software tells the software that it's going to win, it doesn't try to win by more, which is what humans we tend to do, but it just tries to up the probability of winning by just one. So at some point the computer starts making what look like conservative moves, but they are not really conservative. It just doesn't care about destroying its opponent. It just wants to win, and the definition of winning is having one more point. AlphaGo does some tree searching, reminiscent of what Deep Blue did for chess, but the main difference is that the evaluation function is not coded like the chess function for Deep Blue was. It's learned using a deep learning network, and we will see in quite a lot of detail in a couple of in the next video what learning an evaluation function means. But the key idea here is that no one sat down and wrote down a long list of rules of how to evaluate a Go board. Instead, many Go boards were given to the computer, and the computer was told, in this situation you end up winning, and in this situation you end up losing. And using what amounts to image recognition, this deep learning based software, this AlphaGo, was able to recognize, to learn an evaluation function and to recognize by looking at the image of the board when it was winning and when it was losing. Then it explored the tree of possibilities and decided every time on the best possible move. So how is AlphaGo different from Deep Blue? As we said, there is no group of experts designing a long set of rules. The evaluation function is learned. Also, AlphaGo use general purpose algorithm. Some of the parts of the algorithm used in AlphaGo are the same used in the image recognition software that won the ImageNet competition, and that would be used in other ways. In some senses, and this is very not very rigorous to say, but in some senses, the way AlphaGo works perhaps resembles a little bit more how humans think, because AlphaGo is able to learn to fine-tune this function with many variables, that is able to see relationships in these configurations of the board that give it an indication that it's winning or it's not winning, and decide on that. And perhaps, and I'm not categorically stating that, but perhaps that's also how human intuition works. And that's how, very briefly, how DeepMind managed to create a program that could play Go. Go is perhaps a not so important seeming example, because it's just a game. But using those same ideas, and after this massive milestone in artificial intelligence and in the deep learning had been reached, first we had the image recognition thing with ImageNet, and now we have this Go playing system. Then deep learning kept evolving, and all of these ideas kept being applied to different things. Deep learning can also do structured data analysis and predict client behavior and sales prediction, and that was used from the beginning. Some of the drivers of deep learning research were big companies trying to, of course, gain some profit using this for things like client behavior prediction and these kind of things. And it can also do natural language processing, and we saw an example on the History of AI video about how Google Translate is working nowadays, but it can do many things, and one of the most popular is ChatGPT these days. In the next video, we will be speaking about how did this happen? How come suddenly we had all of these sudden advances that seemed impossible a few years before? And why did it happen at that moment?